was told.
I mean,
Yeah, well, that's what they said was on the sign, and then I was told something else, so. Okay, so we are going to continue to talk about the integral today. So we know the integral is the same as the limit of the sum, right? And we've been doing, we know we can do left, right, or midpoint sums to approximate it, but to get the real answer, we had to do the limit as n went to infinity. And it turns out to be quite a bit of work to do that, especially if you don't start at 0, it gets pretty nasty. Now, there are a couple results. We have been integrating from A to B. The first property says if you need to flip those, if you want to go in the opposite direction, it's just the opposite of the integral. So if I integrate from 0 to 4 and I get 5 for my answer, then if I integrated starting at 4 and going back to 0, it would be negative 5. So it's like negative if you do it in reverse. The second thing, if you integrate from A to A, it equals 0, which should make sense if I'm thinking about some curve and I wanted the area from here to here. I didn't go anywhere, so there's no area, so it's 0. So if those limits are ever the same, we just get a 0. All right, the next slide is the really cool one of the day. So we've been doing all of these integrals by going backwards and putting it into the limit and the sum notation. Well, it turns out we don't have to. The integral, the area under the curve, means the antiderivative. And haven't we learned how to do antiderivatives already? And if we want to integrate from a starting to a stopping point, it's just the antiderivative of the top one minus the antiderivative of the bottom one. And we can get our number from there. So that's how, if you ever asked me to check to see if you got the right answer on them, I was able to look at it and tell you real quick if you had the right final answer, because we just have to integrate. So for instance, if I said I have the integral from 3 to 7 of x squared, well, what's the antiderivative of x squared? And what else were we putting on those every time? Plus c. Okay, well this says we just have to do that antiderivative from 3 to 7. So usually when we do that, we change that integral to a vertical line, just to show that now we're going to plug those in. And if I do that, and 1/3 times 7 cubed plus c, that's what I get when I put in 7, minus if I put in 3 1/3 times 3 cubed plus c. All right, 1/3 times 7 cubed. 7 to the 3rd is 43 over 3 plus c minus 9 minus c. What happens to my c's? So we have 343 over 3 minus 9. And gives us a 316 over 3. And that is the same thing you would have gotten if you did the whole change in x, x sub I, sum, and then limits. I know. So here's the question. Was it necessary for me to put the plus c? We need it for an antiderivative, but what happened when I plugged in my numbers? They canceled out. So if we have what's called a definite integral, so an integral with numbers from starting to stopping, you are welcome to leave off that plus c, because it will cancel every time, and it's just unnecessary to have. Now, if I have an indefinite integral with no limits, that means we're not getting a number answer, we're getting a function, then you have to have that plus c. But if we have numbers to plug in, there is no need to include it. So since I just did a sample one, why don't you guys find the integral from 0 to 3 of x squared? So antiderivative of x squared is 1/3 x cubed. You can include the plus c, but we don't have to because we know we're plugging in numbers, it would just cancel. So we get 1/3 times 3 cubed minus 1/3 times 0 cubed. Because you have to do your ending minus your beginning. What happens if you flip those and you put the 0 first? You'll get a negative, the opposite. And we had that theorem that said if you flip them, it's just the opposite. So this would be 9 minus 0, so we just get 9. Is it possible to have a negative answer on these? Yes, absolutely. It just means it's below the axis. All right, what about this one? If I wanted the integral from a to b of x to the n power dx. All right, so I'm not going to get a number here. We're kind of having an expression. But in general, when you do an antiderivative, what do you do to your exponent? So what do I have to put in front? I'm going to evaluate this from a to b. Now you can write the 1 over n plus 1 with both terms if you want. You can also coefficients. You can just pull them out in front. Like this one we saw, they both had a 1/3. Would it have been the same thing if I wrote the 1/3 out in front and did 3 cubed minus 0 cubed? Yeah. So if you want to do that just to save a little writing, you're welcome to. So I would do b to the n plus 1 minus a to the n plus 1. So that's our expression. Okay, if I knew a and b and n, I could get a final answer. But just kind of looking at what we're doing on those. Let's try another one. If I want the integral from 0 to pi of sine x dx. Remember, the dx just goes with the integral. So we really essentially kind of ignore that when we're doing the antiderivative. It goes away when the integral symbol goes away. What is the antiderivative of sine? Negative cosine. And we're going to evaluate from 0 to pi. So that means we have a negative cosine of pi minus a negative cosine of 0. All right, we're going to figure this out without a calculator. Pi is here. That's like the order pair -1, 0, right? Cosine is x, so the cosine of pi is -1. So the opposite of -1, +1. Minus a negative would make plus cosine of 0. So at 0, my point is 1, 0. So cosine is, and this one gives me 2. Alright, you guys do this one. Antiderivative of x to the 5th. From 0 to 2. So I can, if you want, you can pull your 1/6 out. So you have 2 to the 6th minus 0 to the 6th. 2 to the 6th is, so we get 64 minus 0 is 64 over 6. Alright. Going well? Next one. Alright, so we have to do this antiderivative term by term. What is the antiderivative of 2x? Okay, minus the antiderivative of x to the -1/2. So if you add 1 to the power, it's a positive 1/2. You put the reciprocal in front, which is 2. Minus, what's the antiderivative of 3? I need to evaluate that from 1 to 9. So if I put in a 9, 9 squared is 81, minus 2 times 9 to the 1/2, or 2 times the square root of 9. The square root of 9 is 3. Minus 3 times 9 is 27. Then 1 squared is 1, minus 2 times the square root of 1, minus 3 times 1. So we get 52? You trust me, that's dangerous. Is that one alright? Let's look at this one. Alright. So normally, if we had like something squared, we'd probably take it and multiply it out. If something's to the third, we certainly could multiply it out, but it's going to get a little bit longer. And if I start making fifth, sixth, seventh power, we definitely do not want to have to multiply it out. So let's think about this. If you did the derivative, what would you do? Chain rule. So you would first bring down the exponent, subtract 1 from the power, right? So let's do that in reverse. So if I add 1 to the power, that would be a 4. So what goes in front? Then if you were doing the derivative, 4 comes down, subtract 1, you would take it times the derivative of the inside, which is 2. So to cancel that, we have to multiply by 1/2. So this antiderivative is 1/8 times 2x plus 1 to the 4th. And we're going to evaluate from 0 to 1. So you can pull out the 1/8 if you want. If you put in a 1, 2 plus 1 is 3 to the 4th. Minus, if you put in a 0, you get 1 to the 4th. To the 4th is 81 minus 1. So you get 1/8 times 80, which is 10. So you have to make sure you're watching for that chain rule. Let's try another. What is the antiderivative of sine? When we do the derivative of a trig function, the angle doesn't change, but if you were doing this derivative, you would then have to do times the derivative of the inside. What's the derivative of 2x? 2, so what would we need to cancel that? You knew the question I was going to ask.
Yeah.
How can you check if you're not sure if your antiderivative is correct? Do the derivative, and you should get sine of 2x. So always check it if you need to. Okay, so I could pull out my 1/2. If I put in pi over 2, 2 times pi over 2 is pi, so we get cosine of pi. Minus, if you put in 0, that's cosine of 0. Alright, what was the cosine of pi? Minus cosine of 0. So you get negative 1/2 times negative 2. Or positive 1. Any problems with these? Can we do a product rule in reverse? Okay. So this is secant x tangent x. Does anything have a derivative that is equal to secant x tangent x? Yes. Huh?
Yes.
Isn't it?
Derivative of tangent is secant squared, but the derivative of secant is secant x tangent x. So the antiderivative of this is just secant. Okay. Pi over 4, that's like 45 degrees. Secant's reciprocal of cosine. Cosine of 45 is radical 2 over 2. So if you flip that, so we 2 radical 2 over 2, or
Radical 2.
minus secant of 0. What is the cosine of 0? 1. Reciprocal of 1 is?
1.
Alright, I want you guys to try a harder one. See if you can figure out this one on your own. So antiderivative of square root is the same as the 1/2 power. So if you add 1 to the power, that would be 3/2. So that means you need a 2/3 in front. But we have to think we would do the chain rule here. So times the derivative of the inside is 3. So to cancel that, we need another 1/3. So your antiderivative is 2/9 times 3x plus 1 to the 3/2. I'm going to evaluate from 1 to 5. And so if you put in a 5, you get 16 to the 3/2. So that means like the square root of 16 cubed. You put in a 1, you get 4. So the square root of 4 cubed. So square root of 16 is 4 to the 3rd, 64 minus 8. Times 2 gives us 112 over. Is that good? Let's look at this one. Suppose an animal population, P of t, initially numbers P of 0 equals 100, and that its rate of growth after t months is given by P prime of t equals 10 plus t plus 0.06 t squared. What's the population after 10 months? Okay, so this is how the population is changing. So if I want the actual population, what would I have to do? Antiderivative. Starting at where? We began at time equals 0. That was our initial population. We started with 100 animals. But our time, since t is our variable, and we end when the time is 10. So we have to do the antiderivative of 10 plus t plus 0.06 t squared. And if you have an integral, you have a dt on the end. Okay, so if I do that, antiderivative of 10 would be 10t. Antiderivative of t would be a 1/2 t squared. Antiderivative of t squared would be t cubed. So if you divide 0.06 by 3, you get 0.02. So if I plug in my 10, 10 squared is 100, times 1/2 is 50. 10 cubed is 1,000, times 0.02 gives us 1. Minus, if you put in 0, you get 0, and we get 1/7. That is not my final answer. What am I missing? What did we have a second ago? We started with how many animals? 100. What we just did is the antiderivative of the population growth. So we found out how much the population grew by. So it increased by 170. But we already had 100. So if we add the 100 we start with, now we're up to 270. Does that make sense to everybody? I'm stopping here for today. Just kind of like we did previously, I have one packet for you, but this is for today and Monday. So I have to finish these notes before you can do the whole thing. Technically on this packet, you know how to do 1 through 18 now, but I won't grade it until Tuesday.